I welcome you all formally to our webinar on project scheduling. In this particular webinar, we will explore various project scheduling methods. And before we start, I want to know a bit about you. So as usual, let's start with the first poll, where I want to know which role you are playing in your organization. So role not necessarily is equivalent to your designation. It is more to do with like how many project managers do we have in this particular session, or the people who are leading teams but they are not yet project managers, or testers, developers, or something else, maybe a business analyst. I should have created a separate segment for it, but yeah, I'm capturing remaining into others. So as of now, I can see that we have a majority of project managers. So a few more to go. And let me share the data with you also. So now you can see that we have majority, 36% of our participants are project managers. And then we have a second majority, which is others. So out of these three roles, they are not finding any one of them suitable for them. So it's okay. So mainly the project managers lead are the one who are the major population in this particular session. Another poll, which is more to do with the PMP certification. So I want to know how many of you are preparing for PMP certification. Like, where do you stand in your PMP journey? Are you done with it? Are you already certified or preparing, planning to give exam in the next 1 month? Or just started thinking about it, that what is this PMP is all about, so wondering that what should they do next. So that will help me to know the remaining population well. Okay, so as of now, I'm finding that majority of population with our participants are already certified, so which is good. So let me share the results. So we have 46% of the participants who are already certified. So that makes the event more interesting, because I have also kept it to some generic concepts rather than focusing too much on exam. It is more to do with the type of scheduling we would like to see in our day-to-day life. So done with the first set of polls, and let's start with the content. Now this particular session is all about scheduling. Now what is scheduling? We want to know how should we organize our work, our team members' work, so that they can produce something at the end of the day. So we need to have some way of organizing our own activities and the activities of our team members. So scheduling is an effort, is a type of activity or a management thing which we do, which helps us in knowing what should I do next, what are the expectations which I can make out of my team members. So in order to do that scheduling, we need to have some framework, like how am I going to arrange my work? I need to have some method or process in place. For example, one method which we keep observing, that we will make a list of activities, and after that making list of activities, we may just schedule them. That okay, in a day, a lot of time people do a day level scheduling. They plan their activity and then they schedule them that, okay, after 10 o'clock I will do this, 12 o'clock I will do that, and 1 o'clock I will have lunch. At least everybody schedule their lunch timing. So this is a type of method we are using to schedule our activities. Now in project management, the framework which helps us in scheduling is called scheduling methods. Now these scheduling methods helps us in organizing our activities, in allocating resources to those activities, in visualizing that if we follow this pattern, when can we finish our work. So these are the scheduling methods. Scheduling methods generate schedule data or schedule model. Schedule model is like a database of our activities, which tells us that this is how we are going to we possibly can work on a given project. Out of that data or out of that schedule model, we develop a final schedule. So in order to develop a final schedule for a day, for a month, or for a year, we start with one particular scheduling method. And in this particular session, we are trying to discuss 3 scheduling methods. The first one, which is the most popular method, is a critical path method. The second one, critical chain method, and the final one is about pull scheduling. In PMBOK, it is usually known as agile type of scheduling. So we will talk about these three scheduling methods. Now, critical path. So assuming majority of you are already PMP certified, knowing from my poll 46%, and the remaining 16-17% people who are planning to give PMP exam in the near future. So I am assuming that you have a good base about critical path. Still, so on top of it, then I introduce some of the critical paths features. In critical path, we make list of activities and then we arrange them on the basis of their relationship between those activities. For example, like if I want to make a critical path for going to an office, I will make, okay, I will get up, I will have a breakfast, I will do a preparation for my meeting, I will wear the clothes, etc., etc., and finally I will leave for an office. So if I list down all these activities and then I make a schedule of these activities, and by way of identifying dependencies, like I can't wear the clothes before I have a bath, something like that. So we make those relationships, and after making those relationships, we identify what would be the duration I am estimating in order to get ready for the office. So in a critical path method, we drive these activities, we drive the relationship among those activities, and on the basis of the relationship and the estimated duration of these activities, we identify what would be the project end date. Now, when we are identifying these activities, we do a forward duration calculation, which is called forward pass, and we also do a backward pass. While doing this forward and backward pass in critical path method, we estimate early start, early finish dates. Now, early start, early finish date represents that in order to meet my project targets, earliest I can start this activity as per early start date, and the earliest I should finish this activity is as per early finish date. There could be a late start and late finish date also. Now you may wonder, why do we have a 2 date? Why can't we just work on a 1 date? We start on one particular date and we finish on another particular date. Now in a critical path method, you identify various combination of activities, and these activities will get performed in parallel. So some activity may run for long duration, another parallel activity which is performed by another resource may get finished soon. So each activity is not of the same duration, and that is why the path which represent the longest duration calls critical path, and the activities which are not following in a critical path may have slack. So in order to identify slack, we work with late start and late finish date. So let's move forward. Things will get clear as we get 2, 3, 4 more slides. Now, as I said, in critical path method, each activity is related with another activity. There is a dependency. So we talk about in language of predecessor and successor. So activity A, activity B, which could be a successor, they will have some level of relationship. So 4 type of relationships are used in critical path method. Finish to start. It talks about that, let me finish before you start. So you can't start till the time I am done with my work. So this kind of relationship is called finish to start. Finish to finish is a type of relationship we talks about that we both have to finish together. Like you can only finish. So rather than saying together, I would use the language, you can only finish when I am done. So you may take more time, but you can only finish when I am done. You can't finish before me. Start to start, you can only start when I start. You can't start before me, but you may take more time to start. But start to start relationship talks about, let's start. Let's wait for me to start. Start to finish is a reverse type of relationship. Let me start before you finish. So you can't finish till the time I am starting my work. So such kind of relationships helps us in building the dependencies and critical path. Now it's a relatively big topic. Here I'm introducing at a level which gives you a brief idea about this particular method. Now critical path is the longest duration path in a network diagram. Now what happens, a lot of time people, most of professionals end up visualizing a critical path or a network diagram same like a distance problem or a travel diagram. So if I have to go from one city to another city, I have a many possible ways and I can take the shortest path. But when we are talking about critical path, that is not the objective. You need to finish all the activities, be it they are coming on a critical path, be it they are not coming on the critical path. But since you have to finish all the activities and the sequence of activity which are coming as the longest in your project plan denotes the critical path, because this much time project will take to finish, because you have to finish all those activities, and this is the earliest the project can finish. So the advantage of defining critical path is that if something goes wrong on those sequence of activity, your project duration may extend. And that is why project manager usually keep their maximum focus on the activities which are following on critical path. Now, you might have studied critical path before this particular session also, but there are a few things I want to point it out. For a good critical path uses, you should have logical relationships among all the activities. So you should not create activities in your project schedule which are not having dependencies or which are just hanging. The open-ended activities should be the starting and ending of the project only. So in a good critical path, activity should have a predecessor and activity should also have a successor. And in order to make good critical path, you also need to estimate activity duration very realistically. If your estimations are not predictable, you think that it will take 4 days and you end up spending 5 days or 7 days for that particular activity, it will disturb the complete path. It can happen once in a while, but if it is happening every day, then the critical path way of scheduling will not work for you, because you keep modifying the same project schedule and the successor activities will remain confused when they have to start. Now, critical path as a method, you can apply some constraint like finish before this date, cannot start till this date, or we can apply lead and lag type of constraints also in critical path uses. Now, when the method allows you to put all these constraints, but it is recommended as a best practice not to use constraints till the time it is very necessary. So avoid using constraints when you are using a critical path method. Now, the challenge with the critical path method is a lot of time when we use the critical path type of scheduling in IT projects, it becomes very unrealistic, because in software type of projects, it's very difficult to estimate activity duration with realistic number. There are so many uncertainties which keeps changing the activity duration, and when the activity durations are frequently changing, so if I am dependent on the previous activity and I am waiting to start at 11 o'clock, now the previous activity which was expected to finish on 11 o'clock, it is not finishing till tomorrow. So I'm confused, what should I do next? So I end up going to the project manager and ask, what should I do? Because as per your plan, this activity should have finished by now, but I think it will not going to finish. So it increases the interaction among the team members and project managers end up taking ad hoc decisions, because when somebody goes to him and tell that this activity is not finishing at 11 o'clock, it will finish tomorrow, at that point of time, he don't have a resources or time available to visualize the critical path again, because it is changing every other hour. So in such kind of environment, uses of critical path becomes challenging. Okay, please post your questions. Till the time you are thinking about questions, let me post a poll which will give me some idea about the understanding which could have been developed by this particular segment. So I want to know, knowing a critical path, and most of you might have already heard about various life cycles which are taught in PMBOK. In which life cycle model do you think the critical path method would be most suitable? Where should we use the critical path method? I have just received 50% of the votes, so maybe there are three life cycles which is introduced in PMBOK. The predictive life cycle is a type of project management life cycle where predicting activities, predicting duration, predicting scope is relatively easy. So we do a lot of upfront planning and then we move next. So that is called predictive life cycle. The iterative life cycle is a breaking the predictive duration into a small batches. So rather than making a 2-year-long project plan, we make maybe a monthly or a quarterly plan. So we break the complete project duration in multiple iterations, and then we plan one iteration and then we move forward. So that is called iterative life cycle. In an adaptive life cycle, we don't have a plan in a way, not that detailed plan for a complete project duration. We have amount of work and we plan for iteration, which could be in a weeks, 2 weeks, 3 weeks, and we pick the work from that backlog and we develop things and move forward. So that is something which is called the adaptive life cycle. So you need to select the least. So I'm getting some messages that some of you have done a mistake because of least and most. Now this is something interesting which you may not get when reading the PMBOK. Now, so here let me share the poll. So actually the question was about least, not most. So maybe some of you have done that mistake. The answer of this poll should be adaptive life cycle. It's a reverse of the opinion which I have collected, could be because of the least. Now, as I said, critical path works well when we sequence the plan in advance. When we tell that after this you have to do this, going forward like this. And we expect that things will happen as per plan. That duration which I am estimating for each and every activities will work perfect. And that is what is a characteristic of predictive life cycle. Now, PMBOK in general, in the project life cycle, PMBOK talks about these 3 life cycles, but the remaining content by default it assumes predictive life cycle, and that is why it gets into the detail of critical path method rather than the methods which can be used in adaptive life cycle. So critical path makes most useful sense when we use predictive life cycle, and it makes least sense when we use adaptive life cycle. Because in an adaptive life cycle, we don't work for a very defined long duration project plan. We work in weekly iterations. So it's difficult to make sequence of activities and with a very predictable activity duration. So thanks for the participation, and let's move to the critical chain. So many of you are critical paths, so good. Let's move to the critical chain, and here I can see some interesting questions coming in critical chain, I'm sure. Now, see, what is this critical chain is all about? So you might have heard from your boss sometime that strength of the chain is derived by its weakest link. So the weak people in your team defines the strength of your team. A lot of time when we used to play volleyball or some other games, then the other team used to identify where is the hole and like where is the weak link, and they used to give the maximum balls near to the weak link because they can make maximum points. And that is what the critical chain method talks about. It talks about that strength of your process is derived by your weakest department or weakest weakest team member. Now, how do we start in critical chain method? We first put constraint in a project schedule. So, for example, we are done with making a critical path. After that, we apply how many resources do we have. Can we really achieve this sequence which we have thought in a critical path method, knowing the amount of resources available to us? And after that, the critical chain also puts the activities which are scheduled into uncertainty. The critical chain method works with an assumption that activities which are scheduled may not finish in their estimated time. Now, the next diagram will show you how critical path method can get converted into a critical chain method, or how we can visualize a critical chain method. So, for example, you have A, B, C, D activities. So, in a critical path method, we will estimate all these 4 activities with some realistic estimates. We will drive the relationship between these 4 activities, and then we will come up with the project schedule. In a critical chain method, rather than estimating activity duration in a realistic number, we do very aggressive estimation. We shrink the duration of activities by 50%. So some of the tools which are used for critical chain, they ask you an estimate, and after that schedule itself slash 50% estimates and says that, okay, you have given the 10 days, now you have to do the activity in 5 days. So they slash all those estimates by 50%, they shrink them. Since we are shrinking them, we assume, we work with the factor that there is a high probability, or we can say there is a 50% probability that person may not be able to finish the work in a given amount of time. So for that, we put buffer at the end of the path. So rather than in a critical path methods, buffers are distributed among the activities. So we come up with the realistic estimates so that each the activity B can predict when I have to start. But in a critical chain method, we just come with a very aggressive schedule, and then we have a buffer at the end, and we keep, whenever something takes more than the allocated time, the buffer gets consumed. So we do all level of monitoring using this buffer. Now, going further, so the critical chain methods are primarily known for feeding buffers and project buffers. So a lot of time when you take PMP questions, you end up looking for the keywords, because you need to just map it. Is it a critical path or critical chain? So you look for a keyword like resource constraint schedule. So whenever you find a resource constraint, you start feeling it is something to do with the critical chain, because there only we put the resource constraint. The second keyword which people look for is a buffer name, like feeding buffer, project buffer. So if they find the buffer names is mentioned in a question, they end up thinking it is something to do with critical chain. You are right, you can use that logic, but let's understand what these buffers are. So as I said in my previous slide, in a critical chain method, we are doing aggressive estimate for each and every activity and putting the remaining amount at the end of the path. That is why we talk about 2 types of buffer in a critical chain. One is called feeding buffer and another is called project buffer. The activities which are on critical chain, you can think of the activities which are on critical path after putting resource constraints, after shrinking them with aggressive estimates, will have project buffer at the end, because the sequence of these activities will drive the end date of the project. But there could be another chain or another path which is merging with the critical chain at some point of time. So for example, the activity G is somewhere getting merged with the critical chain before activity F. So we want in this particular scheduling method, the other paths which are not critical path, if something gets delayed here, for example, if activity B gets delayed here, so the shock of this delay should get absorbed by that path only. We should not shift the shock to the critical chain or activities which are following on a critical chain. So we have a feeding buffer. Feeding buffers are the buffers which are kept at the end of non-critical chain link. And we have a project buffer which is kept at the end of the activities. So this is how the feeding buffers and project buffers are used in critical chain method. Critical chain methods is primarily focusing on student syndrome. So as a project manager, you might have seen this word student syndrome, like work expand to fill the time. So if I allocate more time to activity A, there is a very less probability that people who are doing activity A will finish before the allocated time is over. So we usually keep consuming the complete time allocated to us. And that is why critical change talks about that don't allocate time, just allocate aggressive targets, but do understand, do respect the fact, since you have given aggressive targets, you should have some mechanism which you might have kept at the end of the path in order to absorb the delays which may happen while performing those activities. So final table, I keep getting requests that can we have a summary level table which can tell the difference between critical path method and critical chain method. So when I was making this presentation, I thought of including it. So it is like in critical path method, you might have already observed, we talk about estimating activity duration with some realistic logic. We try to achieve whatever we have estimated. And that is why we work with an assumption that they will get performed as per the allocated time. In critical chain method, we work with an assumption that activities may not get performed in a given duration or in given estimates, because critical path work on realistic estimates and critical chain works on aggressive activity estimates. Now, in a critical path method, we do put buffers, but we put buffers inside each activities. In case of critical chain methods, we don't put buffers in the activities, we put them separately at the end. In case of critical path method, when we observe the project performance, we observe it on the basis of activity level duration variance, like how many percentage of activities got performed in an estimated amount of time. So basically, our monitoring is happening estimate versus actual at an activity level, at a milestone level. In case of a critical chain method, if we are monitoring the project progress, we monitor buffers. We monitor that we have kept 10 days of feeding buffer after finishing 50% of our project activities. How much percentage buffer is consumed? If the consumption of buffer is more than 50%, then it is danger sign, because for the remaining activities, you don't have sufficient buffers. So in critical chain method, monitoring happens by way of monitoring the consumed and available buffers, be it feeder level, be it project level. In case of a critical path method, we talk about the relationships among activities, and the activity which is successor, which is dependent on some predecessor activity, can have a fairly predictable start time. So if I am following critical path method, I know that tomorrow I have to start this particular activity because I got this schedule 1 month ago in my project plan or in my project management information system. But if you are following critical chain method, you can't have such kind of predictable start time for an activity, because you know that the activities which have been estimated previous to me, all of them have been done aggressively. So there is a high probability that I may not start my work as per my initial 1 month old schedule. So in order to facilitate working in a critical chain method, we need to have a continuous information sharing mechanism by which a successor activity keeps knowing how the predecessor activity is performing. We should know in advance, is the predecessor activity is going to finish tomorrow or not. So more amount of communication needed between various groups who are engaged in critical chain method. Critical path method can work with less communication also, because we work in a predictable manner. So here, and I'm ready for Q&As. So till the time you are thinking about questions, let me post a poll. So I'm not getting questions till now. I am assuming that you got what I wanted to communicate via critical chain method. If you have any query related to difference of critical chain, critical path, please post it. Okay, so let me close, and here I share the results. So yeah, rightly, critical chain method is the most popular choice. And yes, here we follow the theory of constraints. And you can think of constraint optimization or a constraint resource constraint schedule. What is this theory of constraint? What is this constraint optimization thing? Now, in general, it talks about that, for example, if you need to deliver something, what is your bottleneck? Like your output is usually a function of how much your bottleneck can produce. So say in a traffic, so for example, if you have a highway, so in between you may have a narrow stretch, and then the number of cars which are passing the narrow stretch determines how many cars can pass in a given duration, because they are limiting the output. So the same way we need to identify which resource is constant. Do we have limited developers? Do we have a limited testers? Do we have a limited business analysts? And theory of constant talks about that whatever is in a limited quantity, try to use that efficiently. Focus too much on utilizing that part of project schedule or that part of resource, and it believes in if you do optimization in the remaining area, it can create more inefficiency than overall result improvement. Okay, so one question, what is the maximum buffer? So I got one question while we were talking about this poll and all. What is the maximum buffer percentage can I keep in a project? Now, what could be the answer? See, let's take yourself as an organization and let's take yourself as a project manager. And I keep giving this an example. So if you need to go to an airport and catch a flight, how early you want to reach there? Now, you don't want to reach there one day in advance, and you don't want to have a situation where you reach after the flight is taken off. So you need to identify how familiar I am with the given city, how familiar I am with the uncertainties which can come in between. So usually the amount of buffer which we put in our air travel or in our travel to an airport is a function of the amount of uncertainty we see in the path. The same goes for the project. The project buffers are the function of amount of uncertainty we see in the project duration. The uncertainties are the function of how uncertain the scope is, which are primarily there are two dimensions. One is called what and another is called how. So what you have to make, how much clear or certain you are about the scope. That's the what part of it. The how part of it is how do you know your team member well? How well do you know your tools? How well you know your technologies? So more you know how, more you know what, your schedule, your buffers will start shrinking. Less you know what, less you know how, your buffers will start increasing because you want to meet the target. Now same thing, if you are not going to an airport, if you are going to an office and you don't care if you get late by 10 minutes or 20 minutes because you can explain that to your project manager or your boss, then you don't put that much buffer again. So this dimension talks about how sensitive the stakeholders are about the project delays. If they are too sensitive, then you put a proper buffers because the flight will not wait for you. If they are okay, they understand that you are doing good, you are putting your effort, and it's okay if you go 10 minutes here and there, then you don't put buffers. You work as you go to an office. Okay, so I got one more question again that can I talk again about the difference between a critical path and critical chain? Yes, we can talk. See, simple idea is in critical path, we are estimating activity duration with a predictable, realistic estimates. In case of a critical chain, we are not estimating activities with buffers, we are estimating them aggressively. And we are also putting, in case of a critical change, resource constraints. Like if I don't have a developers, I don't put load or allocate developers in a project schedule more than what I have. So when I put the constraints as per my available manpower, when I remove buffers from the activities, I come up with a critical chain. But when I am removing buffers, I put them at the end of the path in order to make sure that if something goes wrong in between, the buffer should be able to take care of the volatility. We use critical chain method when we don't have a predictable way of estimating duration, when there is no defined way of accurately estimating a duration. Because in the absence of having a defined and a statistically verifiable method of estimating activities, if we tell people to estimate activity with very much surety, they may end up putting too much buffer. So when we are working on a volatile environment or not that stable environment, we work with uncertain, aggressive estimates. And in those environments, the critical chain method becomes useful. When we are working in a predictable environment and we don't want too much management overhead communicating, this is late, this is done, this is again and again, I am delayed by 1 day, so other activity has to adjust. We don't want those all confusions. We try better to have a predictable activity-based duration so that the people, the activities which are dependent on the previous activities, they don't remain confused. They have predictable start time and end time. And as far as PMP exam is concerned, resource constraint, feeder buffer, project buffer, theory of constraints, these are the 3-4 keywords you can keep in mind in order to map something to critical path. I hope I have answered your question, Roshan. So let's move. Final one, less spoken schedule in PMBOK, and this is all about agile-based scheduling. Now, what is this agile-based scheduling? We will talk about. So I had a webinar before on pull scheduling. Some of you might have already attended it, and we do have a recording of that webinar available in our YouTube channel. So for details, you can follow up on that. It was a 1.5 hour webinar where we get into the details of this pull scheduling. Now, as I spoke about while we were talking about critical path type of scheduling, it works in a predictable way. It works good when we can estimate the activity durations with good accuracy. But what if we can't do that? If things are so uncertain, I might have estimated 1 day for a given activity, but it usually takes more than, it usually get changed when the person starts working on it. And when that happens, people keep coming back to me, asking me as a project manager, what should I do? So things becomes challenging, as we spoke about the challenge of a pull push system or a critical path method. In a pull-based scheduling, we don't allocate work and we don't make sequence of activities. We create work visible. So we make work and workflow visible. So for example, if you are working in a dispatch department, nobody tells you what you have to dispatch. You have an inbox. As you have material in your inbox, you guys are expected to pack it and dispatch it. So nobody dictates what you should do, only that the system is, the work is visible. So if you have work pending, you need to work on it. And such kind of scheduling method is called pull-based scheduling. So how does it work? In order to make this thing work, we need to have a visible list of amount of work left in our project. So that is where the adaptive life cycle comes into the picture, because we are working for short duration. Now this kind of scheduling may not work for a long duration thing, and that is the intent. It has to be scheduled for shorter iterations. So what we do, we create amount of work which we want to do in upcoming 2 or 3 weeks, and on the basis of that amount of work, we make list of it, or we make them visible by way of a sticky note. Now, whenever somebody has resource or amount capacity available, they will pick it and assign themselves. And that kind of work system is called pull-based scheduling, and that is how the agile thing works. So in PMBOK, in adaptive life cycle, you got a brief explanation of how the agile scheduling can work. In the project time management, this is not explained further, but just for your reference, in general, the agile projects has a list of work. So in case of a Scrum, we use the language product backlog. So something which we want to work on. So this is a list of things I want to do in my life. So in earlier days, people used to make 5-year plans, 6-year plans, but you know how difficult to maintain even 1-year resolution. So making plan for 5 years is always difficult things. So rather than making plans and scheduling that I will do this certificate and after that I will do that certificate, we can just make a list of goals or list of features or list of items which we want to finish in near duration. And out of those lists, we pick something for a given month. So we don't have sequence identified because we understand how these item has to be worked on. We pick something and we move them from a defined workflow. So if I'm talking about software development, you can think of that you have a list of requirement, and in a given duration, you pick one requirement and or a set of requirement depending upon your capacity. For example, if you have 3 developers, you can pick 3 requirements just to make it simplified. And then you work on analysis, design, development, testing only for those 3 requirements and finish them. As you are done, you pick the next slot. Now, nobody assigns when the testing should be done. Testing will have their own inbox. So they keep looking how many items have been completed by the development team. As development team finishes the work, testing teams picks the work. So rather than we sequence and we tell them that after this on 11 o'clock you have to do that, we tell that the flow is like this. After testing, after development is over for a given item, you need to do a testing for a given same item. So it's like a production line. So once the books are there, you need to dispatch them, you need to pack them, and you need to put an address on it. So nobody is going to put an address on it. If you have packed book in front of you and if you are free, you should do it. So such kind of scheduling philosophy is called pull-based scheduling. There is a technique called Kanban which makes all these things visible. So we make work and workflow visible in a Kanban. It's like Japanese name which talks about a visual card. So we show that these many items are lying at each particular stage, and items or a work item move from one stage to another before they get completed. And for each stage, we have a defined completion criteria. So you can visualize, like if you go for a car service, your car goes from multiple phases or multiple stages before it is ready for you to take. So all these stages can be visualized as workflows, and nobody allocates them when you submit your car or when you give your car for service. They get allocated as per the capacity available in various processes or various departments. So such kind of scheduling method removes the role of a project manager for assigning work. So this works in a way that make the work and workflow so visual that people know what they have to work on, and project managers should not be allocating work on an hourly or daily basis. So in an adaptive life cycle, when things are unpredictable, we can't make or we can't allocate work for months or years because things are very dynamic. We work with pull-based scheduling. There are various models of pull-based scheduling which we use with different flavors, but the concept, the essence remains the same. So time to take the final set of questions. Now you can ask anything out of those 3 segments because this was our last segment for today's webinar. And here I have some questions. Now, the question has come is that we have different items which may have a different priorities. So how do we allocate them? Now, in a pull-based scheduling, what we work on, if you have a capacity available, you work on it. So I will say in a simple language, I can work on 3 stories. Okay, if I am already working on three stories or 3 features, I will not take the 4th feature. If you want to give me a 4th feature, remove 1 out of my pocket. So I only have 3 slots to service the car. If you think that there is a new priority thing has come, take something out. So now, if you are working in a system where you need to prioritize things, the prioritization has been done for the available capacity. But usually when we work on a Kanban or a pull-based scheduling, when we make 2 weeks schedule, when we pick the work at the initial stage, we apply prioritization. So if I have 100 feature, I will not pick feature just randomly. I will pick the one which are of higher priority. And after picking them, I will work in a sequence where the flow will be driven by the amount of work can be done by the given individual. So that is how the prioritization get implemented in case of primarily in a pull-based system. Now there are various variants. When we talk about Agile Scrum-based methodology, we have continuous prioritization, which we do at the beginning of iteration. When we do Kanban type of methodology in Agile, we don't do at all prioritization. We keep it that I am in a factory. I am like on airport. Whoever comes in, I checks the guy. So I am an immigration officer, and there is a queue. So as people come, I keep immigrating them. I can immigrate one person in a 5 minutes. So if you want to manage priority, just manage the queue. So there are kind of variants, possible variants in a pull system. So I have another question. Is there a way to leverage or use critical path or critical chain method as a part of Agile project management? Yes, there is a way. Now, when we talk about long-term planning, because Agile believes in progressive planning or a rolling wave planning. So when we do release planning in Agile, when we talk about that what we are going to do in a 6 months or 12 months time, we end up visualizing sequencing of features or sequencing of deliverables. Now, in that case, we don't get into at the level of activities, but when we make a release plan, so in a way, release planning includes elements or a philosophy of critical path and critical chain. Now, in Agile, we usually recommend that we should be giving predictable output per iteration. So in a way, that is some way get contradict with critical chain method, where we try to give aggressive targets. But a lot of time as a project manager, we do keep some hardening iteration or some buffer iteration at the end. So if we want to finish the work in 6 iteration, we make the release plan with 5 iteration, and we keep the 1 iteration as a buffer to absorb the shock. So if we are doing that, we are following the principle of critical chain. So in a principle, we use them, but not the way like logical relationships and feeding buffer. In that way, we don't use. So some fundamentals we can use, but not directly. Okay, so another question is, I am wondering that if visual responsibilities like a pull, where every member is aware about what they have to do and when is helpful for the project, why it can't be adopted in other type of scheduling as well. Now, it can be adopted, and the pull-based scheduling is becoming popular in manufacturing environment also. Now, the only disadvantage you can think of for a predictive life cycle project, so talk about predictive life cycle project is, even now in a construction industry, we are talking about lean construction and they are following pull-based scheduling, but they usually have a top level push-based plan, so like a critical path plan, where they talk about how the constructions would be done, and inside the phases, they follow a pull-based thing. So they talk about the site manager for a given site can follow a pull scheduling where work and workflow is visible. But at a project level, if I am managing multiple locations for my same construction project, I may have a critical path and push-based scheduling. And it is becoming popular. The pull-based scheduling is becoming quite popular now, be it manufacturing, be it. So it is usually known as lean planning, lean scheduling. So wherever you find lean is in, so you may think that some way of pull planning is coming in. Thank you, friends. So I'm done with the Q&As which were posted here, and you can interact with me over our forum. So we have a forum.izenbridge.com where we keep posting and replying queries related to PMP and PMI ACP. So thank you. Thanks for joining in, and hope to see you sometime again in Thank you.